Going to talk about how you calculate the area between two curves. I'm going to show you a way of doing this without knowing how to graph the curves. Suppose that you have this curve, say that's f of x, and you have another curve that's always beneath it. Well, if you were to calculate the integral, so let's call this point A, and right underneath this one, let's call it B. If you calculated f of x dx, well, what you would calculate, what answer you would be getting, from A to B, what answer you would be getting would be how much this area is. And now, just to make sure this is correct, we can't have the function going backwards. That's not a function the way I drew it. Oh, it meets there. So you are finding out this area. Let us even move over g of x. That function is g of x. I color-coded it. Okay, so you are calculating this area. So you have the area you want, but you also have too much area. Somehow you want to remove this area because you don't want everything below f of x. You only want what's in between. But now the area that I just took away, that's the area from A to B of g of x dx. And this is nothing more than the area from A to B of f of x minus g of x dx. The top function minus the lower function. That would give me, that subtraction would only give me this area. Okay? Basically, this function gave me everything that's shaded in, everything. And I am now taking away the area under f of x, under g of x. And that gives me just what I wanted. The area in between the two functions. So this formula, you don't have to remember it. You should see it. Okay. It's just elementary school subtraction idea. The first function gave us, once again, everything in green plus this. Gave us everything in green plus this. Everything under this curve from A to B. Gave us everything under that curve. But I only wanted what was in between the yellow curve and the pink and the blue curve, or the purple curve. So that means I want to take away this area. But you know what that area is? Just look at how I'm erasing it. It's everything below the purple curve. Well, if I knew the area of the purple curve, I can just take it away. But I do know it. It's the integral from A to B of g of x dx. Okay. Now, what if I told you, or you calculated, that these curves intersect at A and B? You just said f of x equal to g of x, and you concluded x is A, x is B. But you don't want to graph them. Well, either the f function is bigger, and this will give you the right answer, or the g function is bigger, and this integral would give you the right answer. Now, the thing is that if this is -7, this one will be +7. If this one was +71, then this one will be -71. Why? Because if I factor out a minus sign, then I'll have f of x minus g of x dx. And what I'm boxing is exactly this. It's exactly this. But this has a minus sign in front. That's why if this one is 71, this one will be -71. And if this one is -71, this will be -71, which is +71. They always differ by a sign. So now, if you're told or you calculated, then f and g only meet at a and b. You can integrate from a to b. Pick any function you want to write first. And in case you did it backwards, just take the absolute value of it. Just take the absolute value of it. Okay, so if this turns out to be -71, that meant you should have had g of x minus f of x. But it doesn't matter, because the absolute value of -71 is 71. And if you did have it right, what's in between the absolute value bars is 71, and the absolute value of 71 is 71. Okay, now that's step one. Now, just for the record, well, not here. Okay, now, suppose that you come to learn that the functions intersect in 3 places, A, B, and C. They come to intersect in 3 places, and only 3 places. Well, you know what? It could have just touched there and then touched there again. That's first scenario. Or let me draw A exactly the same, the yellow function exactly the same way. That's the f function. And the g function, well, it could have crossed. That's the second scenario. But it has to touch at A and B and C. In fact, there's no left of A, so there's no top and bottom to the left of A. But in the B, that's where the problem can come up. Now, there's a third case. There is a third case. Once again, there's my f of x. It could have been that g started on top. And you know what? It stayed on top. That's a possibility. That's g of x. The green function is g of x, f of x. Now, let us look at the next case. I think this is the last case. Even if I'm wrong, it's not going to matter, as you'll see in a moment. Suppose that f of x, g of x was initially on top, okay, but then it went below. Okay, so it turns out in this case, you could have just done the integral from a to c of f of x minus g of x, and you would be okay, because the f function's always on top. But you don't know that, because you're not going to graph it. There's no reason to graph it. All you need to do is integrate from a to b, the first interval. Say f is on top. If you're right, that is the area between the two curves from a to b. In fact, you would have been right here and here. You would have been right. But over here, the g function's on top. So you know what? For those two cases, let's make sure we take the absolute value. So you know what? We now even have those two taken care of. Now, they intersected at b. So let's now go from b to c. Integral from b to c. If you wrote f of x minus g of x, this would be right if the f function was on top. Oh, the f function's on top here, so you have that one. And you know what? The f function's on top here between b and c. Okay, but you know what? Maybe it wasn't on top. Maybe the g function was on top. So I take the absolute value. That will take care of this case where I was wrong. The g function was on top. And it will take care of this case where the g function was on top. All I'm saying is this. Without graphing it, you know the two graphs intersected A, B, C, and D. And the functions are f of x and g of x. And all you know is that they intersected those values. So you integrate from a to, now this is without graphing it. You integrate from a to b, f of x, gx, dx. Well, this would be exactly right if f was on top, but maybe it wasn't. Who knows? Maybe it was, maybe it wasn't. So I took care of the interval from a to b. Now, I'm going to take care of the integral from b to c. I'm going to write f of x minus g of x. In fact, do it where you'll get a nicer answer. If f minus g is not as nice as g minus f, do g minus f dx. This will be the right answer, exactly the way I wrote it, if f was larger than g on that interval. But in case it wasn't, let's take the absolute value. So we took care of that interval. Now we deal with c to d. We'll do f of x minus g of x dx, absolute value. If your teacher tells you you have to graph these to know whether to do f minus g or g minus x, g minus f, I want you to laugh at your teacher, okay? Your teacher, I'm sure your teacher knows what I'm saying, but what's happening is your teacher just isn't telling you this. Okay, this works like a charm. You never, ever, ever have to graph the function. What you better get right, and you're going to have to get this right even if you graph the function, is where f of x meets with g of x. Now, there's just one more type that may come up. Okay, you may have this situation where the functions, well, let me just draw it a little bit longer, where the functions do not meet at a and b. They tell you to find the area between a and b. That is, you have this wall at a and this wall at b. This is the area that they're asking you to calculate. And maybe that's f and maybe that's g. Well, we know one thing. Before they intersect, one of the, that is from a to c, you find out they intersect at c. You know one thing from a to c. One of the functions is always on top of the other. Why? Because, well, let me erase this. Because if this top function between A and C, so now it's on top, right? And right here, it went below. And I agree, this function is below. But they had a cross. But they didn't. They only crossed at C. That's where your calculation better be right. If you know it crossed only at C, then one of the two functions will always be on top of the other. So you calculate the integral from A to C of f of x gx blindly. That is, you don't know which is on top. And in case you got it backwards, maybe the area should be 13. You're going to get negative 13 if you have it backwards. Oops, now it becomes 13. Okay, and then you integrate from C to B. And again, one function's always on top of the other. Okay, I'm not even telling you if f went here and then went up and g went up and came down. It could have been that g went up and that f went down. But it doesn't matter. This area, in case I do it backwards, taking the absolute value will fix it. And if I didn't do it backwards, this will be a positive number, and the absolute value of that positive number will be that same number. Okay, so don't graph it. Do not graph it. Just take absolute values. If you happen to get a negative answer, like negative 13, call it 13. But the only way you can justify calling it 13 is putting absolute values. And you know what? If you don't want to put the absolute values, that's not so bad either. Okay? But you have to do one thing. If you get negative 13, then put the absolute values. And here, if you get 23, you don't have to put the absolute value. But it wouldn't matter if you do. Okay, there goes my lecture. It was a good one, I think. It gets you out of having to graph these functions, which is painful. Okay, so suppose you're given f of x equals to x squared minus 6x and g of x equal to 0. So we just want to find out where the functions intersect. So you want to solve x squared minus 6x equal to 0. I can factor the second function, and I get that x is 0 and x equals 6. Wonderful. Okay, wonderful. So I'm going to integrate from 0 to 6. I'm going to pick that function to be the first one. Why? Because I'm an expert in taking away 0, which is the other function. I'm less of an expert taking stuff away from 0, because then I'm going to have to remember to change the signs. No way. Taking away 0, that's my speed. That is definitely my speed. So this is the integral of x squared minus 6x dx from 0 to 6. And just in case I should have done 0 minus, I'm going to take the absolute value of my answer. So I'm just going to do the integral normally, and in the end, whatever answer I get, it's got to be positive. This antiderivative is x cubed over 3 minus 3x squared. And this gets evaluated from 0 to 6. So I get 6 cubed over 3 minus 3 times 6 squared. And I hope it's clear that when you plug in 0, you're going to get 0. Make sure that's positive. So now, what I would do here is, I have 3 on the bottom, and I'm going to break off for 6. And And here I have 3 times 6 squared. Well, that's going to be 2. So basically, I have 2 times 6 squared minus 3 times 6 squared. Well, just like if 6 squared was x, or x squared. If you have 2 times x squared, and you take away 3 times x squared, you have negative 1 times x squared. So this is negative 1 times x squared, which is 36. And that equals to negative 36. So I did do it backwards. Final answer is 36. I did it backwards. Let's see if I can convince ourselves of that. Well, this graph equals 0 at 0 and 6. And it is a positive x squared. So it's going to go this way as opposed to being upside down. And absolutely, look at this. Between 0 and 6, this graph is on top of this one. I really did do it backwards, but I don't care. I'm not going to spend my time graphing it. I'll just take absolute values. That really works. Okay, let's do another one. Suppose you have f of x equals x cubed minus x, and g of x is 0. So I want to find out where the two functions intersect. So I set them equal. And on the left, I can factor out an x, and I'll get x squared minus 1 equals 0. And I can factor some more. It's the difference of squares. So either this is 0, that happens when x is 0, or that's 0, which happens when x is 1, or that's 0 when x happens to be negative 1. So in order, it's going negative 1, 0, and 1. So first I'll integrate here, and then I'll plus, and then I'll integrate there. And I'm not going to worry which function's on top. And these are great type of problems to do that for. Because again, this minus this is trivial. It's that. However, this minus that, you might make a mistake. You shouldn't, but you might. We all make mistakes. So I'm going to say that the area we're looking for is the integral from negative 1 to 0. Now this minus that, that's simple. It's x cubed minus x dx plus the integral from 0 to 1. Now it might, let me just finish, x cubed minus x dx. Now it might be that this is g of x and their function at 0, the other function, the cubic function, so at negative 1 they cross. It crosses at 1, and negative 1 and 0. Maybe at 1 it just touched. I meant to say at 0. Maybe at 0 it just touched. So the green function's always on top. But let's not stress out over that. You don't need to graph it. That's nonsense graphing it. Do the next problem instead. Okay, so the integral of that is x to the 4 over 4 minus x squared over 2. And this gets evaluated from negative 1 to 0. And in case we did it backwards, absolute value. Plus, the nice thing is, you can do this integral separately than this one as a test or as a check. Make sure you get the same answer. And this one goes from 0 to 1. But in case we did it backwards, take the absolute value. Okay, when you plug in 0, you're going to get 0. Minus. Well, when you plug in negative 1, you're going to get 1/4 minus 1/2. Absolute value. When you plug 1 in, you're going to get 1/4 minus 1/2. And then when you plug in 0, you're going to get 0. Okay. Now, 1/4 minus 1/2 is 2/4. Well, that's -1/4. So it's the absolute value of that. That's also -1/4 with a minus sign in front of it. 0 minus -1/4 is 1/4. Absolute value. This one we did wrong because we got a negative. But it doesn't matter, because we took the absolute value. So the area is 1/2. Okay. Let us do a few more. Now this one will finally not have g of x being 0. Suppose that g of x is equal to 2x plus 5. So what you do is you set the two functions equal to one another. You set f equal to g. That's f. That's g. First thing is that would take away 2x from both sides. Subtract 5. And you have x squared minus 4 is 0. Say x is plus or minus 2. So you have minus 2 to plus 2. Okay? Now, the nice thing is this answer right here, that is f of x minus g of x, because I actually took away g of x. And there's my answer. I actually have it. So we'll integrate from -2 to 2 of x squared minus 4 dx. In case I did it backwards, in case I should have done g of x minus f of x. This here is f of x minus g of x. I mean, after all, this is f of x, and I'm taking away g of x. And there's my answer. Okay, so x cubed over 3 minus 4x. And we want to evaluate this from -2 to 2. And whatever answer we get, keep the positive number. So when you plug in 2, you get 8/3 minus 8 minus. Now when you plug in minus 2, you get -8/3 plus 8. Absolute value. Well, 8/3 minus a -8/3, that's 8/3 times 2, or 8/3 plus 8/3. And if you take away 8, and then you take away another 8, you took away 2 8s. So it's 16/3 minus 16. Well, 16 is 48/3. And 13 minus 48 is -32/3. So the answer is 32/3, which is 10 2/3. Okay, and I did it backwards. But we covered ourselves by taking absolute values. Okay. Now here's one where it was similar to what I told you earlier. Suppose you have y equals 1 over x squared, y equals 0, x equals 1, and x equals 5. So basically what's going on is you are given, so this is the y-axis, this is the x-axis, you are given a and b. A is 1 and b is 5. Okay, And you're also told that the in between there, and that you're told that y equals 0. Now, nobody's saying that this function and this function meet at 0. Nobody's saying that. So maybe this function goes like that. Okay? So we want this area. Maybe this function 1 over x squared, maybe it goes like this. So we want this area plus that area. Or maybe 1 over x squared is always negative. In that case, we would want this area. So if it's always positive, it's no problem. If it's always negative, it's no problem, because we take the absolute value. But we have to make sure that they don't intersect. Well, 1 over x squared equals 0. This is a fraction. And a fraction equals 0 only if the numerator is 0 and the bottom is not 0. But that numerator is 1. It's never 0. No matter what number you put in for x, 1 divided by that number will never be 0. Keep in mind that this quantity times 0 must be that number. Whatever you plug in for x, whether you get 0 or something else, when you multiply it by that 0, you'll never get 1. 20 over 10 equals 2, because 2 times 10 equals 20. You're never going to get 1. That's never equal. That is, f never equals g. That is, this function and this function are never equal. This function you can think of as f of x, and this function as g of x. They're never equal. So that means either, so we know what g is. It's this line down here. F might be up there or f might be down there. So if it's up here and I do f minus g, I'm okay. If f is down here and I do f minus g, I'm not okay. I need to take the absolute value. But even if I'm right up here and I take the absolute value, all is good. Okay, a lot of talk because I want you to think about this. So, of course, I'd rather do f minus g, because seriously, I'm an expert in taking away 0. There's 1 over x squared minus 0, which is 1 over x squared. Absolute value in case I'm doing it wrong. Now, before I can integrate that, I'm going to write 1 over x squared as x to the negative 2 dx, still from 1 to 5, but absolute value. If I add 1 to that number, I get negative 1. I divide by negative 1, and I have to evaluate from 1 to 5. Absolute value. Now, there's an understood one there. 1 divided by negative 1 is negative 1, and if I bring the x to the negative 1 to the bottom, I get that. I need to evaluate this from 1 to 5. Now, you know what? I hate evaluating when it's negative. So I'm going to invoke that rule. I'm going to call it 1 over 5, but then I'm going to switch the limits. And look at how nice it goes. First I plug in 1, I get 1 over 1 minus, then I plug in 5. And I take the absolute value. And you really should know what 1 minus a fifth is. It's 4/5. And the absolute value of 4/5 is 4/5. Now, that's the answer. Just want to make a quick comment about this. From pre-calc, you should know that 1 over x looks like this. And if we're just integrating from 1 to 5 between 1 over x and y equals 0, that's the area we want. And of course, the 1 over x squared is bigger than or above the y equals 0 curve. So yeah, we didn't have to do it, but who wants to spend time graphing this stuff? You know, you have a timed exam. When it comes to homework, you want to get done with it. You know, even if you don't want to get done with it, if you want to spend 3 hours on your math tonight, well, instead of taking 2 hours to do your homework and 1 hour to study, you know, maybe you can get it down to an hour and a half of homework because you didn't curve sketch, and then you have 1.5 hours to study. It is, no matter how you look at it, it's more efficient. Okay, it's more efficient. And you know, nobody's saying that you had to study math. You know, it could have been math and history. So now you have an extra half hour of studying that you can do for free by just taking absolute values. Okay, absolute values is a time saver. Let us do one more problem. Suppose you're told that f of x is equal to x cubed minus 5x squared plus 7x plus 4, and that g of x is equal to x plus 4. And you want to set them equal. And you know that you're going to set them equal, and then you're going to bring the g over, and you're going to get f minus g equals 0. Well, let's just do that right away. F minus g is 0. Well, the only thing that's really going to subtract are those. You're still going to have x cubed minus 5x squared plus 6x. 7x minus x is 6x, and the 4's are going to cancel. Okay, so now we factor out an x. We get x squared minus 5x plus 6. And then we factor this, x minus 3, x minus 2. These two numbers, they did add up to -5 and multiply out to 6. So this implies that either x is 0 or x minus 3 is 0, which happens when x is 3, or x minus 2 is 0, which happens when x is 2. So what we have is 0, 2, and 3. So we're going to integrate between 0 and 2 and 2 to 3. Maybe we'd be able to go from 0 to 3. So that might be extra work, because we're just going to go 0 to 2. But do you really want to graph this cubic? You really want to graph that? I mean, you can take the first derivative, set it equal to 0, find the critical points, find the y values for the critical points, take the second derivative, set it equal to 0 to find out the concavity and possible points of inflection. But that's too much for me. Now, it turns out that that's f minus g right there. Okay, so between 0 and 2, I'm going to integrate f minus g. And maybe I should have done g minus f, so let's take absolute value. Plus, I'm going to integrate from 2 to 3. I'm still going to do f minus g. And this is going to go from 2 to 3. And once again, there's a 50-50 chance that I did it backwards. So I'm going to take absolute values. And I'm integrating the same function. Okay, so this is going to equal to, the integral of that is x to the 4 over 4 minus 5x cubed over 3 plus 3x squared. And this goes from 0 to 2. In case it's negative, take absolute value. And the integral of that, might as well do it. It's x to the 4 over 4 minus 5x cubed over 3 plus 3x squared. And this gets evaluated from 2 to 3. And you really should make sure that you got the same answer, because you are integrating the same function. Okay, now we evaluate. You plug in 2, you get x to the 4 over 4 minus 5 times x cubed over 3 plus 3 times x squared. I hope it's clear that when you plug in 0, you're going to get 0. That's the first one. Let's not forget the absolute values. Plus. Now something neat's going to happen. Now we plug in 3. So it's x to the 4th over 4 minus 5 times x cubed over 3 plus 3 times x squared. Minus. We plug 2 in. But we just did that here, which was nice. So it's 2 to the 4th over 4 minus 5 times 2 cubed over 3 plus 3 times 2 squared. Absolute value. Okay, now this here is 2 squared times 2 squared. 4 over 4 goes. So we just have 2 squared or 4. This is 8 times 5 is 40 over 3. This is 3 times 4, which is 12. In case we need it, absolute values. Plus, that's 3 squared times 3 squared. That's 9 times 9. It's 81 over 4. One of these 3's kills that one in the bottom. So this is just 5 times 9, 45. Minus 3 times 9, it does say plus. 3 times 9 is 27. Minus, well, we know what it is. It's 40 minus 40 thirds plus 12. Okay. Now, this here is 16. But 16 times 3 is 48. It's 48 over 3. Minus 40 over 3. That's 8 over 3, which is 8 over 3. Plus. This number is 20 and a quarter. Plus 27. That's 27 and a quarter. You take away 45, you get 27.75. 17.75. 30. Yeah. That is, you get 17 3/4. This is going to be minus 17 3/4. The absolute value, this first term, is negative 17 3/4. Minus this, which we just worked out. It's 8 thirds. Okay. Clearly, what's in the absolute values is the same as 17 3/4 plus 8 thirds. So let us do that on the side. What is 3/4 plus 8 thirds? Let's have 12 on the bottom. So I multiply top and bottom by 3. I get 9 over 12. And I multiply top and bottom by 4. And I get 32 over 12. So this is 41 over 12, which is 3 5/12. 3 5/12. So understand there's a plus there. This here is 3 5/12. So we have plus 17 plus 3 5/12. So we have 20 and 5/12 without the absolute value. Now, I multiply here by 4/4, and I get 32/12. And finally, I say that that's get 32/12. Okay, so 32/12, that is 3, that is 2, excuse me, 2, that's 24. 2 and 8/12 plus 20 and 5/12, that's 22 and 13/12, which is, this is 1 and 1/12. That's 23 and 1/12. Minus some silly error, that's the answer. Taking the absolute value, and this problem was not the friendliest problem I've ever seen, but taking the absolute value really played no role in making it any harder or any easier. And that completes this section on calculating the area of a region between two curves. Do lots of these, it's not so bad. And don't sketch, that's a waste of good time. Go do something else instead.